Switch statements. Last control structure. If you remember, we had 7 of them. Okay, the first one was line by line, called sequential. Then we had the selection, which is the if else, and switch. And then we had the repetition, or your loops. And those are the while, do while, and for. So we're going to look into the switch statement. A switch statement is good for enumerating. So enumerated selection, see it right here. What does it mean, enumerated? It means giving a non-numeric quantity a numeric value. So for example, I could say, let's enumerate the days of the week. So Monday would be 1, Tuesday would be 2, Wednesday would be 3. Let's enumerate the months of the year. January is 1, February is 2. We do this all the time. We give something a value that's not necessarily a numeric value. And we could enumerate anything. So normally then, what we would do is we would switch on a value, and this is how the code looks. It's general structure here, bring it in view. We switch on a value, and that value is normally an integer or character. And a switch is just like an if statement, an exact if. Like an exact if. Let me just put this in front. An exact if statement. I'll show you what that means in a second, but here's how the structure of this thing looks. It says switch on a value, and case A would be what the value is. So if the value is an A, it's going to execute case A. Then there's a break. So this says break after each case, or a set of identical cases to avoid error. So the break statement is very important. Remember, the break is either in a loop or in the switch. So breaking after finishing this guarantees that the switch is over. If the value is a B, it's going to do the code for case B. Now look how different this looks. Okay, there's this colon that's after the case, and then there's this break. Okay, and that's how we write them. Now, obviously, we try not to nest these, but yes, it could be nested. So we could have a switch, and then inside here is a switch or a loop, right? But we try not to nest. Remember, we try to avoid, unless we can't get around nesting, then fine, we'll do it. But we try to keep these things flat, nice and simple. So come in here, case A, do that, case B, and it keeps going down. In every case, it's very exact. It does that. Eventually, it gets to the default. This is like an else. So these cases are going to be like the if, exact if, and this is like your else. See, it's a selection, so it should be similar. This do all the other cases. And there's a break here. You could put a break or you could not put a break. The idea is default is the last thing in the switch. It's not a loop. It doesn't come back, so therefore it's over. If you put a break here, it's okay. If you don't put a break, it's okay. I'm going to leave it because it's a good habit to think about the breaks. Here's how it looks as an if. An exact if. If the value is A, execute the code for A. Else if it's B, execute the code for B. Else if it's C, execute the code for C. ... Else if it's Z, all the cases else the default case. So I'm going to go ahead now and look at some examples quickly. This is very straightforward because it's exact. There is no guessing here. It's exact. Okay, so here's the first example. Look at this. A value is 20. Comes up against a switch. It looks for the case 20. It's going to do this case. So what's going to happen is the value times equals 2 is going to get double. It's going to become 40. And when we print it, let's run that and see if we get our 40. Right here, we got 40. Perfect. So that switch statement worked out just so we wanted it. What if I put this as 10? What if I put this as 10 and I run this? Well, obviously, it's going to do case 10, which makes it 20 because we're adding 10 to 10 already. So you could see here, whatever case it is. What if it's not any case that you can see? What if it's like 50, right? There is no case 50. It's going to do the default case, right? So it's going to go ahead and subtract 30 from 50 to get us 20, see? Very exact. If you were to write this with an if statement, it would have been if value equal 10, do this. Else if value equal 20, do this. I'm not going to write it, but you get the idea. If value equal 40, do this. And if value... well, else, do this, because this is the else. Like I said to you, if you put a break here, it's not wrong, okay? It's the same thing. It's just that it's unnecessary after the default. But every other case, we try to give a break. Now, I want to show you something that's a little bit dangerous here, because you see, these breaks are important. Let's put this back to 10. What if I did not have these breaks? Like if I did not have this, what would happen? Let me run this and see what we get. Now, you think you would get case 10 and you'll add it on and you'll get 20, but let's run it. All right, so here we got 40. See, this is dangerous. So what happened there? 40? How did we get 40? Well, that's a crazy thing. How could we get 40 for this? Okay, let me explain it for you. When you don't have a break, in the absence of a break for a particular case, not the default, because normally the default is last. We want to do that last. When you have a case that's not default and you don't have a break, it continues, even if that's not the case. So for example, case 10 is going to add 10 on, so that it's going to be, value is going to change to 20. That's true. But because we don't have a break, it's going to come here. Even though it's not case 20, I know it's kind of weird, but it keeps going. The break stops each case. So if you don't stop the case, it's going to keep going. So then we get to this point and we go 20. Remember, it's changed to 20. 20 times 2, that's why we got 40. See, if I take out this break, you would say, oh, that means it's going to go down here. Absolutely. So let's run that. And what do we have? 45, because it adds the 5 on. Makes sense. And if I take out this break, yes, it's going to go down here and it's going to subtract 30. So we should end up with 15. See, so these breaks are important. Okay, they're very important because the case should be very exact. Now, here's where the breaks could actually come out and make sense. If case 10 and 20 were both multiplying by 2, let's pretend that these two cases would do the same thing. If that's true, we don't need a break between 10 and 20, and we would normally put them next to each other. The reason for that is, if it's case 10, it won't do anything here, but then it'll get to case 20 because there's no break to stop it, and it'll multiply it by 2. If it's case 20, it would not go to case 10 because it's case 20 comes straight here and then do times 2. So these two cases next to each other are two cases that do the same thing. If that's the case, put all of them next to each other and put what you want to happen in the last case. So, I mean, there is no rhyme or reason about these cases here. So let me just make sure we get this clear. I normally put things in order, but these cases don't have to be in order. They just have to be exact. See, if I write this like this, it's the same thing. Let me make this case 10 and run it. See, it gets me to 20. See, the case 40 up here doesn't make a difference. It jumps to 10. There is no break. It goes to 20. It doubles the 10. It gets a 20. Now, if I put 20 here, all right, and I run this, it's going to do the same thing again and get 2 times the 20, which is 40. See, it doubles the value no matter what. So, although I just did this, I don't normally put things out of order. That's just not my style. I tend to put things in order. So one good thing to do is to keep your cases in, ascending order, so that at least they are organized, Now, what if you leave this here to do something and you put case 10? It's going to do both. So you got to make sure, if you know that you want the case to be individual, put a break. If you know a case is the same as the other one, put them next to each other without breaks. Break at the very end of all the cases that are the same. That's the reason why I set up here. Let's go back and you see a set of identical cases. See, you break after they're done and you put what you want to execute on the last case. All right, I'm going to show you a couple more examples and we're going to wrap up. So right now, I have some values here that I need to execute. Let me just look at this one. I said we could switch on not a string. We could switch on a character and an int. So I'm switching on a character, and of course it's case A because that's what C is, and I'm switching on C. See, that's important to realize. You see, value, and I'm switching on value. That's an integer there. This is a character. I'm switching on the character. And of course, when I run this, it should get me an A, right? It should print out an A. Because it's case A, it prints out an A. And if I put case B, it would print out a B. Very specific. This one does not have a default case. Okay, I have to show this because I know a lot of times people take away the wrong meaning. A default case is if you have an else, but if you don't have an else, you could have the cases without default. Yeah. And if that's the case, the last case don't need a break, right? Because there's nothing else to go on to continue. It's not a loop, so it doesn't come back. Just make sure you get that clear. So, yeah, this break that I have here was not necessary. I just normally keep them. It's just a good habit, unless they're all the same case. Different number, but execute the same code. Stack them up against each other without a break. Put the break on the last one and put whatever you want to do on the very last case. All right, I keep saying that, but the question is, what if you don't put it on the very last case, right? Like, what if these two, case A and B, both print A? Okay, let me just comment this out. You know what? Let me just use commenting instead of deleting. Suppose this was the way it runs, right? And this came in as case A, right? Well, there's no break. I commented out. So it's going to do case A and it's going to continue to case B, but case B doesn't have anything to do, so it's going to stop. So it's going to print an A. See that? That makes sense. But what if it's a case B? Let's see what happens. Nothing prints. Why? See, these two are supposed to be doing the same thing, but what they're supposed to be doing is not on the last case before the break. So if it's a B, it won't do anything because there's nothing here to be done, right? So if you want A and B to do the same thing, it's fine to take the break out, but put this here, right? Like make this the case with an A and don't put anything in A. So if this comes as an A or a B, they're both going to do this. How so? If it's an A, nothing gets done here, but there's no break. It continues, it does this. If it's a B, it doesn't even look at this. It jumps straight here and it does this. So both will do this. Be real careful with your breaks. That is literally the only thing you got to pay attention to, your breaks. And then the last one, let's take a look. Now, it doesn't mean you have to always print inside here or do some, thing there. You could do a lot of stuff in here, okay? We don't have to add and do all this. I'm just showing these as we could add a loop in here. We could do anything we want in here. But I'm just keeping it simple because I want to just focus on the structure. All right, so we have an S that's going to update based on the case, right? So we're using the same C from up here. It's case A. So the S should be adding on an A, and so the value of S should be an A. Let's see if we get that. Let's see. All right, let's mess around with some breaks. Let's make around with some breaks. What if we took this break out? Took this break out? What would happen? Well, just like we just saw, it's going to keep adding on. This is a concat. So it's going to take the S, which is empty, add on an A, then take the S, add on a B. I think we might be seeing an A, B, C. Let's see. Here we go. All right, the C here is lowercase. We got to make it an uppercase C just to be consistent. What if we take out the break here? Would it be A, B, C, Z? Sure bet. Very important. If you know you have to break, break. And if you don't have to break, don't. But make sure you're using the right combination of cases in the right order and put the execution of the statement in the right spot. Otherwise, you could get errors. Again, these are exact if. So I could write this as an if statement. I could say if C equal A, do that. If C equal B, do that, and so on. And then I get down to this case, I say else. Or you could write them with else if. Those are actually better because they're more efficient. Else if. That brings us to the end of switch statements, which brings us to the end of all control structures.